optimization. And my guess is that for most of you in this room, in the context of RTB buying, you already have a sense of what optimization means, like what it entails, right? But we at AppNexus over the past few years have found it increasingly helpful to be rigorous about breaking optimization, or more precisely, successful performance buying, into its component parts, or pillars, if you will. So I'd like to share with you what we are currently thinking of as the 3 pillars, fundamental pillars of optimization. And those are allocation, valuation, and bidding. I'm going to talk about each of these throughout today. Now, there is, in fact, we believe, a mythical 4th pillar, which I'm not going to talk about, but it's related to choosing creatives. And let me just say it's something that we are thinking about. It's in the workshop, so we're not really going to say much more about it today. The 3 we'll focus on today are allocation, valuation, and bidding. Okay. Now, let's go back actually. Allocation. This is the problem of choosing the right inventory to buy, that is, where to allocate your budget spent. Now, a trader setting up a campaign or a line item may choose their targeting to figure out which inventory to buy up front. But the optimization system underneath needs to do a good job as well of figuring out whether any individual impression on any piece of inventory is actually worth bidding on, right? Allocating spend towards the pockets that are actually going to work, choosing a yes-no binary decision. Valuation, on the other hand, is determining the actual value, the expected value of a given impression for the advertiser in question, right? Now, second price auction theory, if you've ever dug into it, says that in a second price auction, you'll get the optimal outcome as a buyer if you bid your true, honest, expected value in the auction, what that impression is actually worth to you. And so, probability-wise, you want to find the probability of the outcome and multiply it by the value of the outcome. So valuation then boils down to a classic prediction problem, as we all know, of predicting performance, predicting clicks, predicting conversions, predicting whatever other measurable outcomes you can get online. Ideally using all the variables available to you about, the user, the inventory, and so forth. Now, bidding acknowledges that reality is not theoretical and that we have a repeated auction setting, not just a single second price auction, but many over time. And you may have budget constraints, or there may be auction mechanics factors that muddy the second price waters, or there may be some other overarching business goal that makes it not the case that you want to bid your second price value. So the bidding component here is all about choosing the final bid price, taking the allocation and valuation as inputs. In practice, this often means you're going to shade your bid down a little bit, depending on all kinds of factors. But sometimes, depending on your business goals, you may actually want to raise your bid above your true value because you really want to get that impression. So today, the AppNexus optimization platform, such as it is, has one component, which we internally call V7 for version 7. I guess there were 1 through 6 before it, although they're lost to the legends of time at this point. What this system does is it computes expected values of impressions based on historical data using about 7 variables, including tag, domain, geo, frequency, recency, etc. But the other components of optimization, allocation and bidding, we've left to traders to carry out manually. Whatever they can do to configure campaigns or creatives or line items manually to get the best possible outcomes was left to them. Now, 1 year ago, at this very event, AppNexus Optimize in London, we announced a brand new way of producing valuations through Bonsai, which is the language of small trees, that is to say, decision trees, for the AppNexus programmable bidder. This allows us, and more importantly, anyone, to create decision trees using over 40 variables to create bid prices, to determine bid prices or bid modifiers in real time in order to plug into our valuation component. So this was the first truly programmable functionality in our platform. Now, 1 year later, here today, over 20 different companies have used APB successfully to enhance their performance buying. As of last month, over $2 million of buyer spend went through APB on our platform. And here today, I'm very fortunate to have 2 successful Bonsai users to tell us about their experiences and their work. So, to begin, I'd like to introduce Karl Bunch, Vice President of Global Product Development Demand at Zaxis, to tell us about his work with APB.
Thank you, Jasmine. Thank you very much. So, I thought today I would share a little bit of our strategy. Oh, what's going on here? Oh, all right, here we go. There you go. Thought I would share a little bit of our strategy. How is Xaxis using APB? And how can you get involved in it yourself? A couple of things to think about when you think about this particular problem is the industry is on the verge of a revolution. Mark my words this day. By 2020, if you don't have artificial intelligence or machine learning in your environment, in your platform, under your control with systems that you're building and buying media, you won't even be at table stakes. Zaxis is inventing that system for itself now and working with AppNexus on a very aggressive schedule to make things happen. But that being said, it takes time to do the data science. The things that we're focused on is how can we significantly increase the efficiency that our traders are doing today and invest in how we should be buying media in the future. We want to leverage our data scientists. We want to be able to have them build amazing algorithms that help our advertisers be successful. But at the same time, we need to pay the bills. We need to prove that what we're doing is worthwhile. We need to make our traders' lives better. Zaxis is innovating today on APB, and we're going to talk a little bit about the strategy and how we're doing that, and then we'll talk about some results so you can kind of see how we're actually making money using this technology. So our approach to APB is born of entrepreneurialism. I've spent a lot of my life as an entrepreneur, and I'd say a couple things about that. Number one, we believe in rapid iteration. Anybody here ever heard the term fail fast? Right? Learn. I have no problem with mistakes. Make them creative. Don't repeat them. Learn. The other thing that we believe in is we believe innovation happens at the edge. The people that are trying to make these campaigns work every single day. We operate in 44 markets, 1,500 employees, $1 billion+ in media. I can't be everywhere at all times, but they're members of my team right here. I consider them my most important asset. They're out there every day. So we believe innovation happens at the edge. And so we're developing our systems so that they're basically internally open sourced. Anybody can contribute to them. The UI, the tools, the technology. This allows us to innovate today at the edge and bring those innovations in and scale them out to all the other markets. So as a company, we're capturing that knowledge right out of the box. Meanwhile, though, while we're innovating today, think about it. I just said something scary up here. I need to have a really powerful system in order to compete as the future comes and unfolds. So we need to invest in tomorrow. We need to take the wins that we have today. We need to inform the research that our data scientists are working on with real information. What's really working, what's not working. And then we need to take those investments and scale them. Anybody here familiar with this other bullet which says, always be shipping? That's Jeff Atwood, by the way, if you're not a nerd. Jeff Atwood started Stack Overflow. Anybody know about Stack Overflow? It's a nerd site you go so you can cut and paste little snippets and try to make your life a little better. But Jeff says, always be shipping. He said this in 2007. It's really important. Continuous learning comes from continuously shipping and pushing things out. At Xaxis, we're actually releasing every 3 weeks. And I'm a little disappointed it takes that long. but the team's trying to do everything they can to make that faster. And then, of course, carpe diem, seize the day. At Xaxis, we're building a platform. We call it CoPilot. The basis of CoPilot is very important. I think it's important to realize that augmented machine intelligence is going to be the future of media trading. Financial trading is cool. You can do interesting things with it. But media is a person-on-person thing. And you still need to have that context. So we believe in the CoPilot idea, which is build that system that empowers our traders to be smarter and have the ability to do it at scale. Let's talk about a couple things we've done. I'll talk later a little bit more about our strategy in more detail, but we've kind of approached this in a rapid iteration way. Anybody here a data scientist? How many data scientists we have here? Oh, okay. Anybody who employs data scientists? Okay, a couple of us. To be clear, I'm not a data scientist, but I do play one on the internet. Given that, what we needed to do right away was figure out what could we do with these amazing things that AppNexus was giving us the ability to do. So we built a system. One of them was the recency system. This is a tool where people can log in. Everybody here knows what a retargeting recency strategy would be. Basically, how do I intelligently bid? Our traders do this every day. Sometimes, in some markets, they're putting 130 campaign objects in. Some of them are putting at least 5 because they figure they've got to have a couple buckets. Instead, we built a tool where they could do it with one campaign. They could use this tool and, oh, by the way, get amazing results. I mean, we're talking about 75 times the conversion rates. We're getting the message in front of the right person at the right time. And that's what we're doing with the recency tool. That tool, I wrote it. Literally. It's a bunch of JavaScript code and a little bit of Python. It wasn't amazing. And I believe there's a lot of people in your organizations that today could write a tool like that. It's just that you need to unlock that, and you need to use APB to do that. Let's talk about another one. Anybody here dealing with viewability in your markets? It's going to come. I'm telling you. In the US, this is it. It's over. Conversation done. In your markets, you're going to be dealing with viewability. Brian and I were arguing about this a lot. It was great. Lots of wonderful conversations. Catherine's team came up with an amazing capability in APB. We immediately built that into CoPilot, put tools to it, and put money to it, and started learning immediately. We fed that information back to them. They made some adjustments. We improved the tool. That tool is iterating. Every 3 weeks now, we're releasing a new version of that. We're going to have a new version out now. It's much more visual, easier for people to use the heuristic understanding of situations. This thing was almost 3 times more performant. You know what's more important? Is it delighted our customers, right? Anybody here want to turn down budget? Our budgets went 6, 7, and 8 times what the original budget was because our customers were delighted. And you know what's even better for me? It actually makes my heart feel better. How many people here actually trade? Like logged into console and traded in your life? How many have traders? I hope all of you have traders somewhere. They would stop me in the hallway and say thank you. Right? I mean, we were creating a place where these tools give them the ability to stop and spend time. When we finished the recency tool, one gentleman told me that they spent 3 hours doing their recency. Now it takes them 30 minutes. And he didn't throw away the other 2.5 minutes and go to the pub. Now he uses that to think about his campaign. We're freeing these people's minds to use the best part of them. And that's what we're doing in APB. I talked a minute ago about the parallel paths of investment. To me, you need to be able to do both pieces. You need to be able to build for the future, but invest in today. Take the learnings from today and then put those into your investments in the future. For us, we use these 2 types of terms. We say automated models, big data, data science, magic in a box, whatever you want to call it, brilliant, artistic math. That's important. I believe that's the only way you win in the future. So we need to make that investment today. But at the same time, all of us are out there. Your traders are doing battle today, trying to help their advertisers get the right message to the right person, right? So we're building templated models. These are simple models with the idea of being able to iterate rapidly. We release them within days sometimes of somebody coming to us and saying, hey, we'd love to do this. And we get it out, we do tests, we play with it. So, how do you get started? Well, let me tell you the easiest part of your job. Talk to your traders. Get your engineers and your data scientists and your data analysts and somebody in the business in a room and talk. And pick one thing. Something simple. Don't make it complicated. Something you can measure. Don't make it something odd or strange that's difficult to measure. Pick something that you can measure. Click rates, whatever is important to your team. They are struggling today, I guarantee it. Take that, agree on how you'll measure it, build a manual implementation quickly. I promise you, you can do it. I personally have written Bonsai. It is not scary. Some of your traders are smart enough to do things in Excel that, quite frankly, I can't do. Give them a minute, let them get up to speed on Bonsai, invest the time, let them build it. Sorry, I went too far forward. And then the final thing I would say is scale this through UI, iterate rapidly, and repeat. Thank you.
Thank you so much, Karl. I believe that's the first time I've ever heard that APB frees people's minds. It's pretty good, though. I'll take it. And now to hear about a totally different approach, I'd like to introduce someone else to the stage, Matt Herman, Associate Director of Marketing Platforms at Wayfair, which is a large e-commerce company which runs the vast majority of its advertising campaigns, its marketing campaigns, in-house, and has recently partnered with great success with AppNexus using APB. Welcome, Matt.
Great, thanks, Catherine. So as Catherine mentioned, at Wayfair we do the vast majority of our marketing in-house, and over the past year and a half working with AppNexus, we've leveraged APB to build our own proprietary in-house display advertising platform, which we call Magellan. And the goal of doing that was to be able to leverage our insights into our target audiences in a very granular and customizable way to substantially improve the efficiency of our display programs. So today I'm going to kind of tell you a little bit more about what we built on top of APB and how we did that. So before we do that, I want to give everybody a brief introduction to Wayfair and who Wayfair is. So Wayfair is one of the largest online destinations for the home. So we sell all sorts of stuff, mainly furniture, home furnishings, decor, home improvement, etc. We are a company that, although we sell a lot of furniture, we're very much a technology company and an analytics company at heart. We take a data-first approach to almost everything that we do. We're headquartered in Boston in the US, but we also have operations in Canada and Europe. And the one piece of context I should give you about the marketing team is we work very closely with other portions of our organization. So we have data scientists who sit directly with us, and we also have dedicated engineers who work with us. So now I'm going to kind of tell you a little bit more about how we measure marketing campaigns and what our ultimate objectives are. So at the end of the day, what we're really trying to do on display is maximize the incremental revenue we make from running those campaigns, subject to a cost constraint that usually varies by different types of audiences, depending on what we know about them. So ultimately, we want to make as much money as possible at ROI targets that we have. We very much view marketing as more of a profit center where we want to invest as much as we can to grow the business, assuming that it's efficient, as opposed to more of a cost center where we're managing towards budgets. So to do that, we need to do three key things. The first is leverage data to make decisions and make the most effective decisions that we can. So this is very much about figuring out who we want to serve ads to, and also when we want to serve them. and what the optimal message is. And ultimately, if we do that right, we hope that we'll be able to reach the right audiences who are either going to come to the site for the first time and sign up, and then ultimately go on to purchase, or potentially reach people who we haven't seen in a while and get them to come back to the site to purchase again. And we also want to do that in a very cost-effective way, where we're bidding the right amount for every user, and we're not overpaying for people who aren't going to convert, and for people who we really need to get in front of with ads to be successful. We want to make sure that we're paying enough for those people. That's an overview of our goals. In order to achieve these goals, we chose to work with AppNexus, and specifically build on top of the AppNexus programmable bidder, to make sure we were able to use our data as flexibly as possible and make the campaigns as efficient as we possibly could. So let's discuss how we approach collaboration with AppNexus and our approach for building on top of APB. So when working with APB and also with other partners that we use for display, it's really a three-pronged approach that we take. The first is sophisticated modeling that's executed by both our marketing team and also our data science team. And then once we have those models, we need to onboard them into the platforms that we're working on. So that's really all about programmable bidding. And then assuming we're smart and we win a whole lot of ad impressions, then the last step is we need to figure out what ad creative to show to our users. So that's, in the case of display, a lot about personalized messaging, and make sure we leverage all of the recommendations and things that we have in-house on display as well. So we can start with sophisticated modeling. So when we built on top of APB, we used a combination of decision trees and clustering models to figure out how much to pay for different audiences. So what that meant is we incorporated several variables based on user behavior. So we had a long wish list of certain variables that we thought would correlate with likelihood to convert, and we proved that down to certain variables about the audiences that we chose to use. And then given those variables, we computed the predicted revenue that we thought we would get if we reached that audience. And one thing that we also needed to do a lot of was focus on separating out the signals from the noise. If you talk to our team and you talk to our executive team and you talk to others, there's a lot of opinions about what variables really matter in this space. And we tested a lot of them, but what we found over time is that if the models were overly complex, you ended up modeling noise. So we really need to prune those trees down to the key nodes that really mattered in order to avoid overfitting. So we did that, and then in addition to predicting which customers and which audiences were most valuable for us, we also needed to go through our log level data to essentially figure out the optimal frequency caps that we wanted to use, and also to look at anomalous sites that weren't behaving as expected. So one example of that is we have brown lists now with sites that are good, have very viewable impressions, are good places to serve our ads, but happen to either do auto refreshing or churn through ads really fast, and so we'll have custom frequency caps for those. So it's a combination on the modeling side of building those trees, but then also leveraging the insights we know about how the ads work and practical implications of serving those ads, and making sure that those two work together to build the right models. Once we do that, the next step is programmable bidding. So we need to take the models that we develop and then onboard them into the different platforms that we're using, in this case, APB. So what we do is we take the decision tree, and then we have custom code that we've written that will turn that into a Bonsai tree. That's reasonably straightforward to do. The hard part for us was to figure out the right way to implement those models to achieve our goals. So we started with CPM bidding. So just for every node in the tree, that was a combination of inventory characteristics and user characteristics, we bid on a CPM. And that worked okay, but what we found was we really want to take into account more nuance about the sites that we were on. And it turned out that to do that, we would need a tree that was 10 gigabytes, because we needed to copy all of the same data that we used for conversion prediction, and then underneath each of those have data about the different sites that we could potentially land on. And that just wasn't feasible. And we also realized that AppNexus has a huge amount of data on how different sites perform. And we want to leverage that. And so what we ended up doing was we switched from CPM bidding to CPC bidding with a bid modifier tree. And that was kind of the best of both worlds because it allowed AppNexus to predict response rates on ads, something that AppNexus has tons of experience with and is very, very strong at, and let us focus on predicting the value of different audiences at a really granular level, which is something that our team is incredibly good at as well. And then we merged those two together to come up with a bid. And then the last piece I'll mention is once we win those bids, we really want to make sure we're serving the right message to the right user at the right time so that our ad dollars go as far as possible. So we have also built our own technology to serve ads and to leverage all of the same recommendations that we use across all of our platforms, whether that's display, email, on-site, and so on and so forth. And what's really cool about this is because we're working with an open platform like AppNexus, we're able to bring our own tech to do the ad serving and leverage AppNexus for the stuff that where we really need a lot of help, which is on the access to the inventory and the programmable bidding. So that's kind of an overview of what we built. In terms of results, they've been outstanding so far. Building on top of APBs really enabled us to unify our marketing efforts. We talked a lot about display, but because we have full control over the campaigns that we're running, we're able to coordinate what we're doing on display with all of our other channels, which is really exciting and a huge win for us. There's also a lot of transparency into how the campaigns are performing. We get lot level data that tells us how each node in our trees are doing. And then that creates a feedback loop that enables us to figure out what are the nodes that are doing really well where we need to bid up, and what are the ones that aren't necessarily optimized where we need to figure out a different approach. So that's unified marketing. The second key improvement, and I think we touched on this in the previous presentation a lot, is streamlined workflow. We could build everything we were building with a whole lot of campaigns on top of the API, but making changes would just be very tricky and very error prone. APB is great for us because we're able to change the models over time with very, very simple changes. It's one switch in console to onboard a new model. So that's been great. It saved us a lot of time and enabled us to iterate much faster. And then the most important thing is we were seeing really strong results from a financial perspective. We're getting more profit out of every dollar we spend on display through APB. Since we launched, we've probably cut our CPCs in half. That's been driven mainly by better bidding on our end and also improving having the AppNexus optimizer help us figure out which sites have the highest CTR. So we've seen CTR double over time. And all of this has enabled us to continue to test and learn and reinvest some of the savings back into the program. So that.
Great. Thank you so much, Matt. Thank you so much, Matt. So as you can see, there are some very different ways to use APB, Bonsai, to get great results. Now, one theme of Matt's presentation that I just wanted to call out here is that he emphasized that they broke their prediction into two parts. One, a click prediction that AppNexus handled, and the other, a user prediction, like which users were most likely to add value that they handled, and then combined the two over time. That's a theme that's going to recur, so keep that in mind, a little bit of foreshadowing for you. Okay. Now, 1 year ago we announced Bonsai. So it seems only fitting that 1 year later we should have something else exciting and new to introduce. And I'm going to do it right now. I'm announcing that we are now supporting, or will soon be supporting, custom logistic regression models in AppNexus Programmable Bidder, in addition to decision trees. Now, if you're not immediately excited by that fact, let me bring up someone, Abe Greenstein, who is the Director of Data Science from AppNexus, to tell us a little bit more about logistic regression and why it's a big deal both for my internal data science team and why we're excited and why you might be excited as well. Abe?
So, yay regression. You guys should be excited. I'm extremely excited. Not even faking it. Regression. So why? So why am I excited is that my team's responsible for building the next generation valuation models here at AppNexus. And we are moving to a world where we're going to use the same infrastructure you are. We use APB. That's going to be our backend. It will allow us to iterate models very quickly. And I want to do logistic regression. So it lets me make better models. Now, I want to be clear that logistic regression is a complementary technique to the tree. Doesn't replace the tree. They both have their places. I have some fake regressions here to show you how they differ. On the left plot, I have fake data and a fake logistic regression. And what's nice about logistic regression is that it has a very simple, it models the relationship between, it models the relationship in your data very simply, much simpler than a tree. So here in logistic regression, I have a one-dimensional regression, and I'm able to represent the relationship in the data with one free parameter. In the tree, I have a more complex relationship in my data, but this takes 5 parameters, one to determine each split in the tree. Now there's pros and cons to both. The tree has higher freedom in functional forms. That means it's susceptible to overfitting. But it can capture more complex interactions. An additional thing with the tree is a technical limitation. The good Dr. Paul does not like timeouts. You'll meet him in a minute. But when I first uploaded the tree into APB, it was this giant, beautiful, machine-generated tree, and he almost had a heart attack over timeouts. For that reason, you all have size limitations on trees, because it doesn't scale quite as well as the logistic regression model. So what's very exciting about the regression is that we can incorporate a gazillion different variables. There's a ton of signal in our data. We have a wide data set. And I want to incorporate all those variables to get the best prediction possible. And I think for this large data set, for certain problems, not all, but certain problems, logistic regression will get us the best results because we could dumbly throw everything in there, regularize the model, and get a decent prediction and exploit our data. All
right. Thank you, Abe. If you want to hear more details about the technical aspects of logistic regression, math aspects, so forth, Abe will be leading a breakout after this, so feel free to attend and ask him all the nerdy questions that you want. Okay. Now, if you were here last year to hear about the Bonsai announcement, you may recall that that portion of the AppNexus programmable bidder was enabled by some deep, low-level technological advances in our real-time platform. And the same is true for logistic regression. There's something deep and low level going on. And here to tell us about it is the good Dr. Paul, Paul Khuong, principal engineer at AppNexus.
Does this work? Yeah. All right, so Abe's team and I, my team, we have an interesting relationship. They tend to ask for things, then I give them, I'm about ready to ship, and then they ask for more. So what happened last year, pretty much as we were walking off the stage, is Abe told me, you know what, trees are really nice, but it would be even nicer if I could take a weighted average of 10 or 20 trees. That would be great, right? What if I could have decision forests? Like, you just want weighted averages, right? Are you sure? You don't want not like more math, perhaps? And it's like, no, never. Just weighted average, that's great. And then, so we went back to New York. Abe did something, got a kid. And then he came back to me and he's like, you know what, I was wrong. What we want is logistic regression. This is gonna be amazing. Logistic regression, watch my words, is gonna change APB. So I started talking to people internally, to clients, and as always happens when you talk to data scientists, you realize they ask for one thing, but really they want like something way bigger. So they said, yeah, right, so yes, the TLDR is logistic regression. That would be great for the first step. But really in the future, what we want is a generalized linear model, right? Wouldn't it be great if we could choose what functions we use to map from this infinite space to probabilities or to like expected lifetime values? So this is a spec I got. from my discussions is, you take a bunch of inputs and you spit out a value. Like that's just not useful. But I tried to work with it, and after a while I decided that the way to go was to just have a small set of math operations that we can support efficiently, and represent everything, all the GLMs, all the generalized linear models that they might want to use as a sequence of operations, and this kind of mini assembly language. So that's very flexible. Still have to figure out how to represent it in a way that doesn't take too much space in RAM and that we can execute quickly. The first thing we notice is that a lot of operations are repeated. So let's say you want to execute a GLM. The first step is to take a dot product. That's just a long sequence of multiply accumulate operations. So instead of having 10 separate instructions, you could say, well, I'm going to have 10 multiply accumulate instructions, and then only have the arguments for that operation. Then same thing for, now I want one exponential, I want one multiply accumulate, and then I want one inverse to get like a logistic regression. And that's nice because our vector is so small, we know we can represent almost everything in 16 bits for the indices. So in terms of space usage, we end up having the same space usage for any sparse linear transformation as we'd have for a sparse matrix and compressed row or compressed column storage format. So space usage is preserved. It's also more flexible. We can still do interesting stuff like apply a dense structured linear transformation before doing your prediction. We're probably not going to talk about why that's interesting, but trust me, it is very interesting. And it's also much more flexible. Right? We have a bunch of linear operations, but we also have a ton of nonlinear operations that let us go from not just doing a matrix multiplication, but also mapping these weighted sums to probabilities or like dollar values with nonlinear functions like, say, a log normal regression or logistic regression. And the very nice part is that this is all still vectorizable. Once we take a step forward and we say, right, we're not going to have only one logistic regression model. We're going to have 4 models that describe different parts of our problem. We might say I have one model for the click, then another model for click to conversion, and then perhaps the last one that tells me the value of the conversion. Because now we can learn each one of them separately, and that's easier to train, and for me it's easier to execute. Because now I have like independent streams of operations that can do all at the same time. And that's what computers are good at. They're kind of not very good at doing one thing sequentially, but they're good at doing 10 things at the same time. So, thank you.
All right. So one thing that Paul snuck in there is that although today we're announcing logistic regression is a special case of a broader set of models, supervised learning models and general linear models. So when we asked for logistic regression, Paul, I guess, anticipating what we might ask next, started thinking about building out generalized linear models and already has a framework in place to allow this to be done at scale, which is exciting to all of us. Okay. Now, he also foreshadowed my next point, which is that in addition to adding support for custom logistic regression models in the platform, we will be supporting conditional model components, which is to say that instead of having to do one grand prediction for your evaluation, we will enable you or us to build out different sub-predictions. That is to say, like as Matt demonstrated, we can do a click prediction based on seeing an impression, and then a separate conversion prediction based on seeing a click, and multiply the two together. Actually, there are any number of ways, probably finite, but still large, of decomposing a probability prediction, and we'll support many of these so that you can mix and match. AppNexus already has a viewability prediction, so if you wanted to factor a prediction by viewability, we can do that today. You might even want to predict the expected value of a customer over their lifetime, say, once they've made an online conversion. Again, something that we're hoping to support here. All built in and made parallelizable by Paul's code. Now, this way, you, potentially, can use Bonsai or logistic regression, whichever one suits the prediction problem at hand, to build out the conditional model components and feed them into the valuation part of the platform. But this is not entirely hypothetical, because Abe and his team are going to be using this same system, dog fooding it, if you will, for our own internal project, which we've affectionately nicknamed Tomato Juice, because it is V8 to come after V7. And there's a well-known beverage based on 8 vegetables called the V8. So the point is, he and his team are going to be building out these conditional model components as well, based on our platform data. And you, or anyone using our platform, or at least the goal is for you to be able to mix and match whatever components you want to build with whatever components we have to get the best prediction accuracy at the end of the day. A true platform component system. Okay. Now, I started off by giving you these 3 pillars, and you might have noticed that allocation and bidding have been sitting there lonely for a while, with no little arrows pointing in or out. Not an oversight on my part. We are in fact making investments just as significant in the allocation and bidding boxes as all of these investments on the valuation side as well. And so, here to tell us a little bit more about those future investments is Whitney Schumacher, a product manager from AppNexus.
Okay, so today I'm going to tell you all a little bit about the allocation, valuation, and bidding features and functionalities that we're currently building to help support you in reaching your goals on AppNexus. So the first problem that we kind of look to solve is maybe one of the biggest problems in buying RTB, and that is that there's just too much inventory to really learn on effectively. For every single new campaign that your traders launch, you have to spend money and a significant amount of time to actually figure out which inventory is going to perform. And traders figure out lots of different ways to get around this. Between a level of strategy and tribal knowledge, people guess which inventory might perform well, but at the end of the day, it's really just not efficient. So to help solve this, we've created Ranked Discovery, which takes your campaign data and our platform information to help determine which inventory is most likely going to perform on your campaign, and then starts your campaigns by actually pushing most of the budget toward that inventory in order to help you learn smarter and get to performance more quickly. Now, once you've figured out what inventory to buy, either via Ranked Discovery or via your own narrow targeting, you're inevitably going to run into a problem. Some of your inventory is not going to perform. Who in here has spent money on non-performing inventory? Who in here is lying? So every single time that traders start a campaign, they can be losing thousands of dollars sitting and waiting for reporting to come through so that they can run a report, find that non-performant inventory, and then manually exclude it from each individual campaign. It's really just a huge time and money suck. And so with what we've built is dynamic discovery. And what dynamic discovery does is it utilizes an analysis that our data science team has done to figure out a likely point at which an individual piece of inventory is not going to perform toward your goal. And then within minutes of hitting that threshold, we actually stop buying that inventory. So all of that manual exclusion that you were doing before is completely obsolete. You're able to use our automated systems and stop buying that inventory faster. So buying new inventory is actually not only a problem in allocation, it's also an issue in valuation. In addition to all of the really amazing stuff that you've heard about earlier today, we've actually been making some platform improvements on valuation. And one of the biggest problems that traders run into when they first buy inventory is that you don't really have great information on new inventory. In addition to not knowing how how much inventory is going to cost, you also have no idea how it will perform. And so that black box actually leads people to stop buying new inventory and stop exploring for potential scale that's just out there. What we've created is market rate estimation, which utilizes size, inventory, hour of day, and geo to help really granularly determine what the price point is at every win rate. And by leveraging this, you can start buying your campaigns at the estimated minimum price, which is the absolute least you can spend to buy brand new inventory. And you can keep spending that until you're able to gather enough data in order to have a true expected value for inventory. So now that you have all of this information, you know what to buy, you know basically where to buy it, the last hurdle you have to cross is bidding. How do you take all that information, all of these different inputs, and actually go out and bid most effectively? And traders have thousands of ways to do this. You hear tales of people who can get you twice your performance for half the money. But at the end of the day, all of the inputs to this problem change every minute. And it's impossible for a human being to go into a system, change the lever, click save every single minute for every single campaign. And for our part, we've created, to start, bid price pacing, which will actually, at the most basic level, vary your bid based on how you're pacing toward goal. But in addition to that, bid price pacing also enables us to do a lot of really granular bidding optimizations for you to help push your performance goals. The first of these is custom or smart spend curves. Now, if you have a campaign that's actually targeting the UK, today, what we'll do is we'll try to pace toward a linear spend curve. So every single hour of the day is allocated the exact same amount of budget. But instead, the inventory availability for the UK actually looks a little bit more like this top graph here. With custom spend curves, we're actually able to go in and look at your business goals and say, hey, since you are targeting the UK, why don't we pace to the UK inventory availability curve? And that enables us to help you better reach your goals. So the final thing here is a little bit bigger picture. And it's a hard problem to solve. And that is that not all of your business's goals are about exactly delivering your entire budget and exactly hitting all of your performance. There's more nuance to it than that. And traders add that in every single time they're creating new campaigns. But for our part, we're working to automate that as well. And we're doing that in two ways. The first, Explore Exploit, enables you to determine the minimum amount of budget you want to continue to allocate to finding brand new inventory, as opposed to exploiting the inventory you already know will perform. The second is Prefer Delivery, Prefer Performance. And what this does is it addresses the essentially age-old question of, is it more important to spend my entire budget, or is it more important to hit my delivery goal, or hit my delivery goal or hit my performance goal? And what this allows you to do is input that information into our system so that every automated system that I talked about today will actually take that into account. So all of our systems are working toward the most critical goal to your campaign. So that is a little peek into all of the new improvements that we're working on to help support you and your business goals. I look forward to continue this conversation later today in the breakout sessions. And now here's Brian to close us up.
All right. So I think you can tell from all of these different presentations that this has been one of the most important areas of investment for AppNexus over the past year. We have many different people across the company and of course across our partners who are all investing in the same things. This isn't really working very well. There is more. So what I'd like to do really quickly is just try to summarize everything you've just heard for the folks who, when Paul started talking, had their eyes crossed and sort of zoomed out, because I was completely understood everything he said. So what we're talking about is a future version of AppNexus console, where not only do you have new tools that let you customize the platform so you can build complex models, you also have a powerful set of new tools that automate things that traders do every day. Basically take the best of what many of you have learned over the past 5-10 years working with programmatic and make the platform just work. And in fact, the name of Whitney's group is called Optimization Just Works. So we're doing two things that seem like they're opposing. On one side, making the most powerful programmable platform ever built, and on the other side, making a platform that just works without any programming. And I think that's actually the state of AppNexus today, investing on both sides of this spectrum. I think one thing that Karl said that was really important is this idea that we're not trying to get rid of traders. In fact, we need people in this process. We need people who can take heuristic knowledge, who know what clients are trying to achieve, and translate that into goals, and use all of this technology, all of this data science, to predict the best ways and to optimize in the best possible way to achieve those goals. So we have this full spectrum of technologies that get you both performance and programmable power. So with that, I'd like to open it up. I think we have a few minutes for Q&A. Whitney and Catherine have stayed on stage for us. I know we talked about a bunch of different stuff. So we have mic runners maybe in the back, got some mics. So we have about 5 minutes for questions if anyone has anything they'd like to ask. John.
How does Bonsai help publishers?
How does Bonsai help publishers? Well, today, we think, and you've seen some data from both Wayfair and Zaxis, that we can use all of this APB technology to dramatically improve results for buyers. And I think at the bottom of one of that slides it said, and we reinvest the savings in more spend. Karl had a piece of his slide that said, when we got better results, we saw budgets increase by 6 to 8 times. So what we're seeing is that if we can make performance improvements, we can get more spend. And by just simple economics, we know that the more spend, the higher the CPMs are. Now, publishers it will not help are publishers who do not have performant inventory. So one thing that we will see is that with viewability prediction, we will see spend shift to more viewable placements. With performance optimization, we'll see that better performing inventory will get more spend. And so we'll see more of a separation from the mean, where I think today people tend to spend very evenly. One thing that's hurt premium publishers is audience buying, where you just follow a cookie around. What we're going to see is that we'll find spend go where it works and pull away from places that doesn't work. So if anyone here is big into building content farms or likes to put inventory way below the fold that's not viewable but still gets post-view credit, that's not going to work in the future world. Your advertising placements have to drive real value for marketers. And I think that's good for the internet. I think that's great for marketers. And I think at the end of the day, it's great for the kind of publishers who are committed to this virtuous cycle. Wait, let's get a mic.
Are you doing anything to stop optimizing towards fraudulent inventory?
It's a great question. So I think implicitly, this should be the case, that fraudulent inventory, non-human inventory, doesn't convert very well. There may be non-human bots that buy furniture. If so, I'm sure that's great for Wayfair as long as they pay and accept the shipment. But actually, one thing we found over the years is that good optimization is very unkind to poor performing bots. And so actually, everything we're doing here almost implicitly biases away from non-human traffic. Of course, AppNexus has spent the last really 18 months investing heavily in removing all kinds of low quality inventory from the platform. So we have sort of all the platform protection layers that automatically zap non-human traffic, that zap poor performing inventory, that zap arbitrage, mislabeled inventory, all these other sources of traffic. But even without that, you would still see smart algorithms moving spend to places where you see performance, or moving spend to places where you see high viewability, or moving spend to places where you see video completes, as opposed to places where those things don't happen. So there's a number of different parts of this system, but going back to this idea of an ecosystem, we actually have a bunch of components that are driving spend towards where it creates the most value, ideally for all of the participants in the ecosystem.
Hello, Brian.
Hi.
Many of the variables that you ingest into the optimization models are inventory related, domain, placement, creative, size, etc. How do you see audience information, audience data, profile information feed into do you see it feed into the optimization engine in AppNexus, or do you think it's something that should be treated separately?
So APB in general is built to take advantage of all sources of data. So what we think of as a segment is probably the most important variable of all of them. If you look at the number of features, segment is obviously one feature, but we have millions of segments on the platform. So you can almost represent anything as a segment. You can represent contextual inventory data as a segment. You can represent keywords as a segment. So when Matt was talking about doing user optimization, he said basically we're using segments and profiles as the primary lever for what we optimize. And that's actually really important. And it's not just first-party data, it could be second or third-party data that plug in. In the logistic regression case, it's the same thing as in Bonsai. In theory, you could input scores, so a user's propensity to buy, it could be their test scores from university. You could plug in almost anything and then build those really nice curves so that you spend more on high-income users or spend more on people who happen to have a high propensity to buy a category. So I think that actually is, if you look at the different components, I'd say user tends to be the most performant when you have either CRM data or intent data. And if you just have sort of demographic data, it's less valuable in our experience. For inventory, it tends to be a good proxy for demographics. So if I went to poll the audience on the most time you spend on sites, I bet there would be some demographic clusters we could build on that. But it's a very nice proxy for some of that basic demographic and psychographic data, which is why you see it broken out with so many pieces. And the third is, let's call it context. So things like frequency and recency. How long has it been since you interacted with an ad? It might be the time of day. It might be the day of the week. It might be the weather outside. Things that impact your mood may well impact your propensity to click or convert. So our goal here is to take all of those different things and then dump them on people like Abe and say, can you figure out what works? And then have him deal with Paul. And they can work together and come back to us and say, here's a beautiful model that actually tells us how people behave. And depending on who you are and what you're optimizing for, you'll see those different components connect in different ways. If that makes sense. All right. Unless we have one last question. I can't see. Here's a question.
Hi, what are the initiatives in AppNexus for helping advertisers to manage audiences?
So in terms of what we're working on for audiences, our main philosophy here is to partner with as many different data management platforms as we can. Many of our advertisers have built in-house data activation or data management platforms. And so we see our role here is to help advertisers onboard as much data through partners, through proprietary systems. We just want as much data on the platform as possible. And so I forget how many data integrations we have. I think it's like 80 something. Yuri, is that more or less the right number?
More or less.
Somewhere around 80. I made it up. But tons and tons and tons of data integrations. We've launched a data marketplace recently where we'll actually manage all of the financial clearing for these data partners. So we're trying to do everything we can to help get as much data to dump on the data science teams as we can. All right. I know we've gone through a bunch of material here. Next up, we're going to go to some breakout sessions. As Catherine mentioned, we've got a breakout session with Abe, who will talk more about all the new capabilities here of these different model types, and he'll also go into how he's thinking about leveraging these new models. It should be a great session. Errol will do another session to talk more in detail about sell-side product. And then lastly, Eric, if you stay here, Eric Hoffer, who you saw earlier, is going to talk about video, along with Douglas Melchior, who's the buy-side product manager for video, and with Michelle Smith, who's the sell-side product manager for video. And I wouldn't be surprised if they have some more fancy videos to show us on screen. So thank you all very much. Super excited about this. And